So now we are going to talk about the other system that we are going to treat, that is the Link 16. So let's start with some of the features that we know that is deployed on IoT, LAN, and IoT platforms. Is mainly used to exchange informations using a standard message format that later I will show you how types and what composition they have. And those message can contain command and control battle management, the command and control to fighter mission assignments, and fighter to fighter information exchange and situation awareness, and voice communications. So some important terminology before explaining deeply some of the concepts are needed, such as the tactical data system, that is normally referred to a host, the network, which is formed by an amount of accumulated tactical data system that is formed by a predefined chain of tactical data by radio frequency signal operating within the line of sight, and also terminal, that is referred as a number of radio sets operating and operating, that means that are transmitting and receiving tactical data from the Link 16 radio frequency network. So now that we know some of the terminology, I am going to start explaining something about the J series messages. This message format is identified by both label and sublabel. The label field is 5 bits wide, and the sublabel field is 3 bits wide. So that allows, as we see in the picture, a combination of 256 message types. So observing the picture, we see that in this table we find, for example, the J 7.4, the J 10.5, and each type of those is a different message with a different type of information. That means that can be information, the situational awareness, some voice communication, and so on and so on. So now let's see the architecture of the Link 16. Use the principle of TDMA. That means that all the units are pre-assigned a set of time slot in which to transmit the data and in which they receive from. So this time slots has a duration predefined that is 7.6 microseconds of duration. So taking into account the time slot that later I will explain how it's composed and all the things, and what is the role of the time slot and all the frequency hopping and those patterns. So taking in mind the duration of 7.8 microseconds, and then inside the system we have 51 frequencies available that later I will talk about the spectrum and how those frequencies are located, the jumpings and those things. And the system use a frequency hopping that is mainly to avoid jamming. As you know, is given the frequency hopping give a pattern, and this pattern is jumping from all the 51 frequencies available on the system, so that avoids completely jamming. And to understand the following picture downwards, I want to define two new concepts that are the network concept, that is the same as I mentioned before, and also the net concept. So let's see the net concept. That is a subset of time slot belonging to the Link 16 network. As we see in the picture, we have different nets in which the aircraft, the troops of the ground base are transmitting data and receiving along these nets. So to understand the architecture better, we need to see the different types of ways to exchange data from along these nets. So each message has a specific format and always have some sort of header and a message contains the header and the message contain words, and the message header specifies the type of data transmitted and has also a track number to know from where this information is given to have a better synchronization with the whole battlefield. So let's start seeing the visit word format. That is the first type in which we find three different types of data words: the initial word, the extension word, and the continuous word. So just it's a standard of this type. The type is a standard, but it's more known as, I told you before, the J series message. So this mainly use the same format of the J series message, but taking into account the header and the message data word. Then we have the variable message format, that is a type that can vary content and length, but inside the information field as we see in the picture, in the message itself, it contains the field and the length. Then we have the filtered message. As you can't predict, this message doesn't have any standard and is mainly used to transmit voice in this type. And then we have one of the most important ones, that is the round trip timing message, that is mainly used to in a terminal to synchronize all the network to receive and transmit data. So let's see how this round trip timing works. So this message is special because support the whole synchronization of the system, because inside this message, within a single time slot, we have the possibility to transmit the interrogation and receive the replay within this only time slot, and that interrogation has an information of how time consuming a measurement of the message will be to have a good and accurate synchronization of the network. So since we talk about the importance of the round trip timing message type, let's go inside the composition of the slots and talk about the division made inside the TDMA architecture. So as we mentioned before, just to remind, each time slot has a 7.8 microseconds of duration, and it's organized in sets called A, B, and C, as we see in the slide. And also inside the network is defined a new concept, that is the concept of frame, which has a duration of 12 seconds, which is a time interval that is more manageable on the requirements of the link system. So taking into account the sets that are divided, the time slots and the new concept frame, we have the frame numerated from 0 to 511, and also interleaved with in cycles from 0 to 511. As I say interleaved, that means that is firstly the C 510, the A 511, and so on on the whole 12 seconds. Each block is at a small time slot. So now you may ask, how is possible to communicate in different nets within the time slot, because it's very difficult to find this way. So let's start how the system use the frequency hopping to be able to communicate in different nets with the time slot. So it's possible due to a unique frequency hopping pattern for each transmission. And as you know, we have 51 frequencies, and if you want to transmit, you have one frequency hopping pattern, I have another frequency hopping pattern, and we doesn't coincide in any of the 51 frequencies. Okay, so observing the theoretical work made by the system, supposedly we have the opportunity to operate 127 nets at the same time. So to organize those all messages and to be able to synchronize very accurate, the architecture defines a network, a terminal that is called the network time reference, which has a time base, and that time base allows all and the other terminals to synchronize the time with that reference base time, and allows a time base for the network time reference and to synchronize all the information on the whole network. So then, with all the explanation before, we have all the components inside the at a time slot, which are the synchronization, the time refining, the message header and data, the jitter, and the propagation. So now that we are inside the whole and a small piece of time slot, in which the digital data will be transmitted all over the radio. So we need some sort of modulation to be able to convert to with the digital data. In this case, the method used to modulate the digital information along the radio is mainly by two methods: the cyclic code shift keying and the continuous phase shift modulation by the carrier signal. This means that the pulses encoded are transmitted during the time slot. So, as we see in the picture, the single pulse has a duration of 6.4 microseconds and then is followed by 6.6 microsecond depth time. And observing the picture and taking into account the frequency hopping technique that is used in the system, it's very difficult to locate at any instant the message due to the hopping from one to another frequency, and taking into account that we have 51 frequencies available. So that gives to the system a high reliability that is good for any type of system to transmit some important data and to avoid jamming, as on the most important that in the military is almost impossible to find. That quality is needed as a high requirement on the military war. Just to close the explanation of Link 16, let's get an overview of the distribution along the spectrum of it. So the Link 16 operates at on the same bandwidth. That is curiosity, because at the same bandwidth designed for aeronautical radio navigation purposes, and you may think, okay, this bandwidth is overloaded and it's very difficult to distribute it the 51 different frequencies. So how this system makes that possible? So that is possible mainly, and as just to remind, the bandwidth is from 960 to 1215 megahertz, as we see in the picture. So the system uses some space jump to locate on that bandwidth with a jump of 3 megahertz. So I hope that you enjoy and understand the theoretical part of how those systems works, and thanks for your attention and have a good day.